Welcome to this video where we are going to be discussing questions from tutorial sheet 1, okay, for Lusaka Medical Apex University. Okay, so you can see this tutorial sheet here, it has a lot of questions on set theory. So we are going to solve all these questions here that you can see. Okay, so there are a lot of questions in this tutorial sheet, so I'll make sure that I solve and explain each one of them. Okay, so for you to access the full video where I'll be explaining all these solutions, okay, please register with us. Okay, so our tutorial program is going at 150 per course per month. Okay, you can inbox me on the number in the description. Okay, so we'll start solving these questions one by one. All right, so the first question is what we can see here. So the first question, they're saying write the following set in set builder notation. Okay, so the first one is the set that has 2, 3, 5, 7, 11, 13. Okay, so the next number there will be what? Okay, so the next number there will be okay, so yeah, so we notice that from 7 there is a jump to 11 there. Okay, so we can't say that these numbers are being gotten at an interval of 2. No. Okay, so these here from their characteristics are just what? Prime numbers. So set A is a set of prime numbers. So how are we going to represent it in a set builder notation form? Okay, how are we going to represent it in set builder notation form? We're going to say set A is a set of all x's, okay, such that x is a prime number. Okay, is a prime number. All right, so we've represented the first set in set builder notation. And then let's go to B. So B, they're saying H is a set that has 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. Okay, so we notice that that set is just a set of all reciprocals of natural numbers. So remember, the natural numbers, we said they are starting from 1 and then 2 and then 3 and then 4. So a reciprocal is just getting 1 and then divided by that number that you can see. So the first one is 1 over 1. The one now we are seeing a 1 here. The second one is 1 over 2. The second one is 1 over 3. Okay, second one is 1 over 4, just like that. So these are reciprocals of natural numbers. So in set builder notation form, we're going to say this is set H, okay, is a set of all x's such that, okay, the x is equals to 1 over n, okay, where this n is a member of what? Natural numbers. So we represented that set H in terms of set builder notation. All right, let's look at the third one there, which is C. So on C, okay, on C we have a set T that has 2 over 3, 3 over 2, 4 over 5, 5 over 6, 6 over 7, 7 over 8. Okay, so what we notice in that set, okay, we notice that this is the set of consecutive fractions where the numerator is 1 less than the denominator. Okay, we can say the denominator is 1 more than the numerator. Okay, we can see that if the numerator is 2, then the denominator has to be plus 1 of that number which is on top there. Okay, so if we get the formula that they are using to come up with these numbers, it just be x is equals to, okay, so we're going to say n and then divided by n plus 1, because we see that all these denominators here are increasing by 1. Okay, and then this n here should be restricted. Okay, so the first thing we're going to say, this n is a natural number, okay, such that this n, okay, is between 2 and 7. Okay, so n is a natural number that is between 2 and 7. So the first one of the natural numbers we're going to get in this interval just be 2 and then divided by 2 plus 1. That is the 2 over 3 we are seeing. The second one the natural numbers between 2 and 7, the second one will be 3, and then we have 3 plus 1. That is the 3 over 4 we are seeing. The next one will be 4 over 4 plus 1. Okay, that's the 4 over 5 we are seeing, and then the next one will be 5 over 5 plus 1. That's the 5 over 6 we are seeing. So we can see the pattern there. Okay, so we are going to say set T is a set of all x's such that x is equals to n over n plus 1, okay, where n is a natural number first of all, and this n is between 2 and what, 7. So this here is the set builder notation for the third question that we can see there. Okay, so this was C. Let's find D. Okay, so D is very simple. So D, we are going in twos. So that is 2, 4, 6, 8, 10, 12, 14, 16, 18. So those are just even numbers between 2 and what? 18. Okay, so we are going to say set B is a set of all x's such that this x, okay, is even. Okay, this x is even, and the x is between 2 and 18. Okay, so this is one way of representing it. We can also represent this set B in another way. We can say set of all x's such that x is equals to 2n, okay, where this n is a natural number and the n is between 1 and 9. So we're going to say 1 and then n, 9, like that. So you can represent this set in two ways. You can use the first one that I used there, or you can use the second one. Both of them will give you the same outcome. Alright, let's represent C now. I mean E. That is E, right? Okay, so E is just a set of vowels. Okay, those are A, E, I, O, U, or that you learned in grade 1. Okay, so they have come again in math in form of what? Tests. In form of sets, I mean. So C, we're going to say this is a set of all x's such that x, okay, is a vowel. Okay, we can make it more solid. We can say is a vowel in the English alphabet. Okay, vowel in the English alphabet. Okay, so that is the set C when we represent it in set builder notation. And then the set F, okay, we see that those letters are just from the word mathematics. Okay, so that's it about this question here. We're going to say set D is a set of all x's such that x, okay, is a letter in the word mathematics. Okay, so we did a similar example that day, okay, when we are looking at tutorial sheet questions for roster and set builder form. Okay, that word I remember it was what word was that? I've forgotten the word. Yeah, but we did a similar example like this one here. Okay, so these words here are just from the word, these letters here are just from the word mathematics. Okay, so that's how we can describe that set builder what notation. All right, so let's look at the second question, which is this one. Okay, so in this one now we are coming from the roster form, okay, I mean from the set builder notation form to the roster form. Okay, so we are listing. So set A, okay, we have, they're saying write the following set in roster form. So the set A is a set of all x's such that x is a positive integer and is a divisor of what? 18. Okay, so meaning we want to get positive integers, okay, that are divisors of 18. Okay, so meaning numbers that can divide this 18 here. So how many numbers do we know that are positive numbers and they can divide 18? Okay, by dividing we mean without leaving a remainder. So we're going to say set A is equals to Okay, so we know that 1 can go into 18, 2 can go into 18, 3 can go into 18, 4 cannot, so it won't be in this set, but 6 can, 9 can go into 18, okay, and itself. So this set here will be a set of positive integers, okay, that are also a divisor, okay, of what? 18. So we've listed set A there. Let's go to set B. Okay, so set B, by description, they're saying a set of all x's such that x is an integer and x squared minus 4 is equals to 0. Okay, so for us to find the values that will be in this set, we just have to find the solution to this equation that we've been given. So the equation is x squared minus 4 is equals to 0. So this will be x squared is equals to 4. So meaning that we have x, okay, is equals to plus or minus the square root of 4. So it means our x will just be equals to plus or minus what? 2. And we know that a plus 2 is an integer, even a minus 2 is an integer. So it means in this set B we are going to have minus 2 and positive 2. These here will be our elements when we list them. All right, so now let's go let's solve question B. Okay, let's solve question B. I mean question C. Okay, that was question B that we did. Okay, so let's look at question C there. So question C, they're saying it's a set of all x's such that x is a letter of the word follow. Okay, so remember that the way we did it for mathematics, okay, remember that's the way we are going to do it even for this follow. We are going to do it in the same way. So we are going to say set C is equals to, and then we are going to list the elements, the letters in the word follow without repeating any letter. Okay, so we're going to say the first one is F, then we have O, then we have L, and then we have what? W. So we are not repeating any letter that comes twice in this word. Okay, so this here is the roster form for set C. All right, let's look at D now. So D, we have that D is a set of all x's such that x is equals to n squared, where n is an integer and x is less than 40. Okay, where x is less than 40. So x is defined as n squared, where n squared is I said integer. Okay, that's not an integer. So x here, n there should be a natural number. Okay, so meaning the numbers 1, 2, 3, 4, 5, and so on until to positive infinity. Okay, so how are we going to list that set D there? Okay, we are going to say set D is equals to, okay, so remember we've been given a restriction here that x should be less than what? 40. Okay, x should be less than 40. So we're finding this x by this formula where n is a natural number, so we can use any of these numbers here. So we're going to say the first element in this set will just be x is equals to 1 squared. 1 squared is equals to 1, and this one is less than 40, so we can put a 1 there, comma. The next one will be x is equals to 2 squared. 2 squared is equals to 4. 4 is less than 40, we can put 4 there. Okay, the next one will just be 3 squared, which is 9. We can also put a 9 there. The next one will be 4 squared, which will be 16, so we can put a 16 there. Next one will be 5 squared, which will be 25, so we can put a 25 there. Okay, the next one will be 6 squared, which will be 36, so we can put 36 there. Okay, and then the next one will be, what is 7 squared? 7 squared will be 49. This 49 here violates what we've been told there, that should be less than 40, so we can't put this the 49 in this set, so we are going to close this set just there. Okay, to just have 1, 4, 9, 16, 25, and 36. So this here will be our set what? D. Okay, so you have to process, guys. You have to think this through. Okay, if you can't think, you won't answer any of these questions. Okay, so sometimes they can give you this roster form here. They ask you to write the set builder. Okay, how are you going to think about this? Okay, so you have to think. Right, so that was D. Let's go to E. Okay, so on E here we have set E is a set of all x's such that x is equals to n over n plus 2, where this n is a number of is a member of natural numbers and n is less than or equal to 7. So it means the values of n that is we are going to take here will just be 1, 2, 3, 4, 5, 6, and 7. Oh, okay, so we are going to use these values here. Alright, so let's find the members that will be in this set. Okay, so we are going to say set E is equals to, okay, so the first member will be 1 over 1 plus 2. That will be 1 over 3. Okay, and then the second one will be 2 over 2 plus 2, which will just be 2 over what? Over 4. Okay, 2 over 4 comma, the next one will be 3 divided by 3 plus 2. That will be 3 over what? 5. And then the next one will just be 4 over 4 plus 2. That will be 4 over 6 comma, the next one will be 5 over 5 plus 2, so that will be 5 over 7 comma, and then the next one will be 6 over 6 plus 2, so that will be 6 over 8 comma, and then we have the 7 now finally, so 7 plus 2, so there we are going to have 7 over what? 9, and then we close the set. Okay, so that will be the values that we are going to have in that set, which is set E. Okay, so we found set E. Let us now go to set F. Okay, so set F will be equals to, okay, so let us read this carefully. Okay, so they are saying set F is a set of OAN, okay, where AN plus 2 is equals to AN plus 1 plus AN, okay, and then A1 is equals to 2, okay, and N is a natural number, okay, and A2 is equals to 4, where this AN is between, okay, not between, but they're saying this AN here should be less than what? 100. Okay, so what do we know first of all from this question? We know that A1 is 2, okay, and we know that A2 is what? 4. So from there we can find our A3, our A4, our A5. As long as that A something is less than 100, it's going to be part of this set F. Okay, it's going to be part of this set F. So what are we going to do now? Okay, what are we going to do there? We're going to write our A1 here. So our A1 is 2, our A2 is 4. Okay, let's now find our A3. So notice that A3, okay, will just be the same as A1 plus 2. Okay, so this 2 here, we can see it in the formula there. Okay, and then there's a 1 there. So we were told that if we have something like AN plus 2, this will be equals to AN plus 1 plus AN. Okay, so A3 will be equals to A1 plus 2 there. Let me write it properly there. So A3 will be equals to A1 plus 2, which will be equals to, we're just following the formula that we've been given there, which will be equals to A1 plus 1, okay, plus A1. Okay, so I'm just following the formula that we've been given there. So what is a1 plus 1? This is the same as a2, and then plus a1. Okay, so we're going to add now. So what is our a2? Our a2 is 4 plus our a1, which is what? 2. So it means our a3 will just be what? 6. So I'm going to write 6 there. Okay, so that is our a3. You have seen the process that we followed there. So let's find our a4. So our a4 will be equals to, we follow the same procedure that we have here. So let's divide this 4 into a number plus 2. So that will just be a 2 plus 2. Okay, so that n now is this 2 here. So this will be equals to an, in this case it is 2, and then plus 1 plus a 2. Okay, so we see that this here is going to be a3 plus a2. So this is going to give us what? It's going to give us a3 we found it was 6 plus a2, which was just 4. So this is going to give us 10. So we're going to put 10 there. Okay, let us find a5 by using the same procedure. Okay, so a5 will be equals to, remember to divide this into a certain number plus 2. So that will be a3 plus 2, which will be equals to a3 plus 1 plus a3. Okay, so this will be equals to, this here will just be a4 plus a3, which will be equals to, our a4 was what? Okay, our a4 was 10 plus our a3, which is 6. So this we are going to be 16. Okay, let's find our a6, and then I'll show you a pattern that we noticed there. Okay, so we are going to say a6 is equals to, remember we are making this a6 to have n plus 2, so that will be a, and then this 6 we divide, we separate it into n and 2, so that n will just be 4 plus 2. And then from this formula we are told that you have something like that, that will be equals to a4 plus 1 plus a4. So this one here will just be our a5 plus a4. So this will be equals to, our a5 is 16, okay, plus our a4, which is 10. This is going to give me 26. So I'll write 26. So what do we notice there? Okay, we just noticed that the next term in this set would just be the addition, okay, of the previous two numbers. Okay, so the first one is 2, quite alright, and then when we start from this 6 here, it will just 4 plus 2, 6, 6 plus 9, I mean 6 plus 10, 10 plus 6, 16, 16 plus 10, 26. So the next one here will just be 26 plus 16, which will give me a 42. The next one will be 42 plus 26, which will give me 68. The next one will be 68 plus 42, okay, which will be 110. But remember they said an should be less than or equal to what? To 100. So which means we can't go to the 110 there. So we are going to exclude that 110 from the set. So we're going to erase this, and then we are going to say our set only ends on the 68. So this one here will be our set what? F. Okay, let us do the last set here, which is set G. Okay, so we also have some formulas there to consider. So set G, they're saying it's a set of all kn's such that kn plus 1 is equals to 2kn plus 1, where this n is a natural number, okay, and k1 is equals to 2. So k1 is equals to what? To 2. And there are no restrictions here, so meaning this set goes indefinitely, okay, it goes to probably infinity, okay, it goes indefinitely. So we are going to say set this is set what now? Okay, we can name it set P is equals to. Okay, so the first entry in this set will be the K1. So the K1 will be what? 2. And then the next one now will be using these formulas here. Okay, so the next one will be K3, which will just, K2. Since this one is the K1, we want to find the K2. So K2 will be equals to, and then we follow the pattern that we have here. So if I have a number here, I have to split it into something plus 1. So that K2 will just be K1 plus 1, okay, is equals to 2K1 and then plus 1. So this is going to be equals to 2 multiplied by K1, which is 2, and then plus 1. So that will be 4 plus 1, which will just be what? 5. So I'm going to say my K2 there is 5. Okay, so I hope you're following the formula. Let's find K3. So K3, we're going to say this is equals to, we have to split this number to n plus 1, okay, as we can see in this formula. So that one will just be K, the n will be 2, and then plus 1, which will be equals to 2kn. So the n is this 2 here, so I'm going to put 2 there and then plus 1. So this is going to be equals to 2, and then the K2 will be 5 and then plus 1. So this will be 10 plus 1. So the next number there will just be what? 11. So I'll put comma 11 there. So comma 11. So we can erase this and then try to find K4. So K4, okay, will be equals to, we split this number, okay, into n plus 1. So it will be K3 plus 1. So this 3 is our n there. So this will be equals to 2kn, the n is 3 and then plus 1. So this will just be equals to 2, and then the 3 is 11 plus 1. So that will be 22 plus 1, which will just be what? 23. So I'm going to say comma 23. Okay, and then we'll just continue that like indefinitely, okay, until you reach forever, because we haven't been given a restriction here. Okay, we've just been told n is a natural number, so natural numbers go forever like that. Even this set will go indefinitely like that, it won't end. Okay, so this is how we can represent this set here in roster form. Right, so thank you for watching. Please subscribe, and if you need extra lessons, you can inbox me on my number in the description here. Alright, see you in the next video. Alright, so let's look at this question here. They're saying let J be equals to 1, 2, 3 and K be equals to 2, 3, 4. Write down in roster form the power sets of J and K. Okay, so what is the power set? Okay, so a power set is simply the list of all the subsets of a given set. So let's say set J there, what we've been given there. Okay, so if we are able to list all the subsets that we can get from this set J, that would be our power set. Okay, so let's get all the subsets from this set. Okay, so the first one, okay, so we're going to say power set of J is equals to, and then we list all the subsets of this set. So the first one will just have 1, okay, the second one will just have 2, the third one will just have 3, okay, and then the other one will be a combination of 1 and 2, the other one will be a combination of 1 and 3. Let me write that properly. So we have 1 and 3, okay, and then the other combination will be 2 and 3, okay, 2 and 3, and then we have the set itself, so 1, 2, 3, and then we have the empty set. Okay, so these here, what I've listed there, they are the possible subsets that I can get from set J. Okay, so they have 1, 2, 3, 4, 5, 6, 7, 8 members. Okay, so the subsets are 8. So remember the formula that we used to use when we are finding the number of subsets. We said we used to use 2 to the power n, where this n was the number of elements in this set. So in this set we can see we have 3 elements, right? So it means the number of subsets will just be 2 to the power 3, which will be 8. Okay, so when we count these subsets here, they are 8. So the most important thing to note is that when you are finding the power set, okay, the set itself is also a subset of itself, and then even the empty set is also a subset of the original set. Okay, so those that is the power set of set J. Okay, let's write down the power set of set K. So set K has 2. Okay, let me put the correct brackets here. Set K has 2, 3, 4. Okay, so how can we list its power set? So we're going to say power set of K is equals to, okay, so the 2 itself, the 3 itself, the 4 itself. Okay, let's combine the 2 and the 3. So we have 2 and 3, and then we can combine the 2 and the 4. Okay, and then we can combine now the 3 and the 4, and then we can get the whole set, which is 2, 3, and then 4, and then we can also get the empty set. Okay, so this here is the power set of set K. So we've done part A there, where they are saying power sets of K and J. Okay, so B now, they're saying find or write down. Okay, so the question is coming from here. Write down in roster form, okay, the power set of the intersection of J and K. Okay, so we are looking for the intersection of J and K, so meaning the numbers that are on, let me say the members. Okay, these are not numbers because these here are listed as members. So we are looking for the members that will be in both the power set of J and the power set of what? K. Okay, the power set of the intersection of J and K. So we can get them from just these ones that we've listed, or if we want, we can first find J intersection K. So what is J intersection K? J intersection K, we are going to have 2 and 3. Okay, so now let's write the power set of this. So we're going to say power set of J intersection K. Okay, so this is going to be equals to the power set. Okay, we can have the 2 itself, we can have the 3 itself, then we can have the 2 combining with the 3. Okay, and then what else can we have from there? We can have the empty set. Okay, so we see that we had 2 members in this set, so meaning the number of subsets will just be 2 to the power 2, which is 4. We can see that the subsets here are just 4. So the power set is just a list of all the possible subsets of that set. So I found the B there. And then here on the last one, they're saying find the cardinality of the power set of J union K. Okay, so it means there we have to find the power set of J union K, and then we count the elements. Okay, in that we find the elements of that set. Okay, so the cardinality, it means the number of subsets. So we are going to be using this formula here that I've been using. Okay, all right, so let's find first of all the union of set P and the set K there. Is that set J, I mean, not set K. Okay, so the set J and the set K there. All right, so let's find the union. So we're going to say J union K is just going to be equals to, okay, 1, 2, 3, and then 4. Okay, so to find the cardinality here, the cardinality simply means the number of subsets of this set J union K. So we're going to say number of subsets, or the cardinality is the same thing. It's just going to be equals to 2 to the power n, where n is the number of elements here. So the number of elements here is just 4. So 2 to the power 4 is going to give me 16. So the cardinality of the power set of J union K will just be what? 16. Alright, so let's solve another question on this same cardinality thing. Okay, so number 4, they're saying write down the power set of 1, 2, 3, 4. So notice that this here is a set. Okay, notice that that is the set. So how are we going to write the power set? Okay, all right, so we're going to write, say, the power set of this set. Let's name this set A. Okay, so the power set of set A, remember we are saying we are listing all the subset in this set. Okay, so remember that this 3, 4, we are taking it as one entity here. Okay, because it's a part of this set. Okay, so it means this set here has 3 elements, so it's supposed to have how many subsets? 8. Okay, so we're going to say 3 to the 2 to the power 3, that would be 8. So we have to list down 8 subsets here. Okay, so it means we've already stated its cardinality there. The cardinality is just 8. Okay, so now let's list the subset. So the first one will be the 1 alone. Okay, the second one will be the 2 alone. The third one will be this set alone, because it's an element there. Okay, so that set alone. Okay, I'm going to write it like this. So notice how I'm writing it, right? Because it's an element there. Okay, so we have to put it between these two curly brackets. Just like the way we've done to the 2, the way we've done to the 1 there, we've put them between these two curly brackets here. Even this set 3, 4, we're going to put it in curly brackets. Okay, and then the next one, we can combine 1 and 2, so it will be 1 combined by 2, and then we can also combine 2. We can also combine 1 and this set here, so we can say 1 comma the set 3, 4. Okay, comma, and then we can combine 2 with that same set, so 3, 4. Okay, so what is remaining now? It's just the whole set. Okay, so the whole set is also a subset, so we're going to write it 2, and then we have 3, 4, like that, and then we write the empty set like that. Okay, so let's count this set to see if there are 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we are done. So that's the power set of this set where we named it as A, and then the cardinality will just be 2 to the power 3, which will just be what? 8 subset. Alright, so that's all for this video. Please like, subscribe, and share to your friends. Okay, for those who want extra lessons, you can subscribe using the number in the description below where I'm pointing there. Alright, let us look at question number 5 from your tutorial sheet. Okay, so question number 5, they're saying use Venn diagrams to represent the following sets. Shade the region being described. Okay, so the first one, we are having A intersection B. So this is the simplest, right? So we are going to draw 2 circles that are overlapping. So this is my B, this will be my A. Okay, so where are they overlapping? It's this part here. So I'm going to shade this part here where I'm shading in what? In yellow. So shade all this part here. So that will be our A intersection B. What about B? They're saying A minus B. Okay, so A minus B, we say it's the same as A intersection B complement. So what does that mean? Okay, it just means shade the part of A that is not in B. So if I draw 2 circles like that, this is B and then this is A. Okay, A minus B simply means, okay, shade the part of A that is not in B. Okay, so we have 2 parts of A. We have this part of A here that is not in B, and then we also have this part of A that is in B. So A minus B simply means shade the part of A that is not in B. So I'm going to shade this part here. Okay, this part here. So starting from there, or this part here. So all that part there is in A and it's not in B. Okay, so that will be the part that I'll shade like that. All right, so let's go to the next one. The next one is the symmetric difference. Okay, I taught you what symmetric difference is. Okay, so the symmetric difference A, and then you have this like a triangle, and then B. Okay, it simply means A minus B union B minus A. This is what it means. Okay, so if I have two circles, A, and then I have B. Okay, so this is our B, and then this is our A. So what this symmetric difference telling us is that I shade the part of A that is not in B. Okay, so the part of A that is not in B is this part here. Okay, that is the part of A that is not in B. I'm being told by this, and then we are saying union B minus A. So B minus A means that we shade the part of B that is not in A. So the part of B that is not in A will be this part here, where I'm shading in blue. So that will be the part of B that is not in A. Okay, so that's how our diagram is going to look. Okay, we are not just going to shade their intersection. Okay, this side we are going to shade, this side we are going to shade. Right, so that's the symmetric difference. Let's look at the D. Okay, so D, we have B minus A union C. Okay, so we are going to use the similar concept that we are using. So I will draw A there, then I'll draw B, okay, then I'll draw C. So this is C, okay, this is B, and then this is A. Okay, so what we have been taught by this part here is that we should shade a part of B that is not present in A union C. Okay, so where can we see A union C? I'm going to trace that with a blue color. So A union C is this part here. Okay, or this part here, where I'm tracing in blue like that. That's the A union C. So we want to shade the part of B, okay, that is not a part of A union C. So that part of B that is not part of this A union C, or this here, is just this part here. So we're going to shade this part, okay, where I'm putting the white line, this part here. Okay, so that's what we are going to shade on this set. All right, let's look at the other one. Okay, let's look at the other one. All right, so now let's solve E. So E is given as B minus A intersection C. Okay, so this here simply means that we shade the part in the set B, okay, where the set B does not intersect with A intersection what? C. So the A intersection C will be this part here that I'm tracing in blue. So this is the part that will be in A intersection what? C. So now let's shade whatever part is remaining in B, which is not part of this blue circle that I've drawn there. So I'm going to shade with red. Okay, let me just choose white. So all this part in B here will be shaded, as long as it's not in A intersection what? C. So all this part here will be shaded. Okay, and we are done for this question. Please like, subscribe, and share with your friends. Okay, for those who need extra lessons, you can inbox me on the number in the description of this video where I'm pointing like that. Okay, so just inbox me on WhatsApp, then you'll be able to register for our tuitions and access the full length video on this tutorial sheet.